One of the quieter consequences of the Korean War was not tactical or political, but cultural. Faced with extreme weather, fractured supply lines, and the need to build fast under pressure, military engineers embraced systems that reduced dependence on skilled labor. Buildings, bridges and shelters had to go up quickly, using standardized parts and methods that could be taught in days, not years. That approach worked in an emergency. What followed, however, was a long-term shift in civilian construction that treated speed and uniformity as permanent virtues rather than wartime compromises. In the process, a body of hard-earned knowledge, carried by carpenters who built for permanence rather than urgency, was quietly discarded. Many of the failures we now accept as normal in modern buildings were problems old carpenters rarely encountered, not because they were smarter, but because they worked under different assumptions. Old carpenters assume materials were unreliable, while modern builders assume they are perfect. Traditional carpenters never trusted wood to behave itself. They expected variation in density, moisture, and grain, even within the same beam. Every joint, layout decision, and assembly sequence reflected that expectation. Modern building systems, by contrast, assume dimensional consistency. Lumber is specified by nominal size, engineered to meet averages rather than extremes. This difference really matters. When materials deviate from these assumptions, old systems absorb the change. Modern systems, however, resist it until, well, something fails. Military planners in Korea learned a similar lesson when equipment designed for controlled conditions broke down in mud and cold. Systems that tolerate variation survive longer than those optimized for ideal conditions. Wood moves. It always has, and it always will. Old carpenters treated that movement as a design constraint, not a defect. Joints were proportioned to tighten as wood swelled and relax as it dried. Panels floated, frames flexed. So, modern construction often tries to eliminate movement with adhesives, rigid fasteners, and sealed assemblies. This approach, it works temporarily, but, well, stress accumulates over time. Cracks appear where movement is trapped. The failure is often blamed on workmanship, not on the design philosophy itself. Old carpenters avoided this by allowing buildings to breathe and shift without tearing themselves apart. Historic buildings, interestingly enough, relied on shape and exposure to manage water. Roof overhangs were generous. Foundations lifted wood away from soil. Walls were layered to shed rain and, dry quickly. These were not just stylistic choices. They were responses to repeated failure. Modern construction often relies on synthetic barriers to stop moisture outright. But when these barriers fail, and inevitably they do, water becomes trapped where it causes the most damage. During the Korean War, units that relied on sealed systems without redundancy suffered when conditions changed. Old carpenters assumed failure was possible, and they designed for recovery rather than prevention alone. Traditionally, structures were really expected to be maintained, components were accessible and replaceable. If you had a rotten sill or a damaged brace, it could be removed without having to dismantle the entire building. This approach required forethought and the acceptance that, no structure remains untouched by time. These days, modern buildings are often assembled as integrated systems, where failure in one area can compromise the whole. Repair becomes complex and expensive, which honestly encourages abandonment rather than maintenance. Old carpenters, on the other hand, worked in economies where replacement was uncertain. Their buildings really do reflect that reality. Old carpenters worked quickly, but that's because they worked deliberately. Layout was resolved before any cutting began, reference surfaces were established early on and protected throughout the process. This careful approach pretty much eliminated the need for rework. Modern builders often rely on tools to compensate for incomplete planning. Adjustments are made mid-process, which honestly ends up consuming time and introducing error. In military operations, speed achieved through planning consistently outperforms speed achieved through reaction. And, well, the same principle applies both in the workshop and on the job site. Traditional framing systems often included more material than strictly necessary by modern calculations. This was not ignorance, it was insurance. Redundant load paths meant that if there was a localized failure, it did not lead to collapse. Post-war engineering culture, shaped by material shortages and efficiency mandates, really sought to eliminate redundancy. Structures met code requirements, but honestly, they lacked margin. Old carpenters assumed uncertainty, storms, settlement misuse, and built accordingly. Redundancy was not inefficiency, it was resilience. Old carpenters, they really favored wooden pegs, wedges, and joints that worked in compression. Metal was used sparingly. These fasteners moved with the wood, tightening and loosening without tearing fibers. Modern fasteners are strong, but honestly pretty unforgiving. They concentrate stress and resist movement until the surrounding material fails. This isn't a flaw in the fastener, but rather a mismatch of intent. Old carpenters, well, they selected joining methods based on long-term behavior, not just immediate strength. Traditional carpenters paid close attention to grain orientation. Beams were placed crown up, heartwood and sapwood were positioned deliberately, and end grain was carefully protected from exposure. These days, modern construction often treats lumber as, well, just interchangeable units. The direction of the grain is rarely considered, except for, the most basic structural requirements. But over time, this kind of indifference, it really shows up. Warping, splitting, and decay become all too common. Now, old carpenters, they didn't have moisture meters or fancy stress models, but they sure observed patterns and adjusted their methods accordingly. Time, believe it or not, was actually an active ingredient in traditional construction. Wood was carefully seasoned until it stabilized. Frames were allowed to settle, sometimes for quite a while, and finishes, well, they were only applied after all the movement had already occurred. Nowadays, modern projects tend to compress timelines pretty aggressively. Materials are often installed before they've had a chance to acclimate, and structures are sealed before they've properly settled. The real trouble is, problems usually appear much later, long after the builders have moved on. The Korean War, for example, demonstrated again and again that rushing systems into service before they were truly ready led to failures that, honestly, cost far more than any delay ever would have. The pressures of mid-20th century warfare, really reshaped construction priorities. Speed, standardization, and minimal training requirements became the dominant values. These priorities made sense under emergency conditions, but honestly, the mistake was carrying them forward uncritically. As skilled labor declined and building became, more industrialized, the carpenter's role shifted from decision-maker to installer. Knowledge that was once held in hands and habits was replaced by specifications and codes. Some gains were real, sure. Others, though, came with costs that are now becoming clear. For those thinking in terms of resilience, the lessons are, pretty straightforward. Expect materials to behave imperfectly, design for repair, not just completion. And, allow systems to fail slowly and visibly rather than suddenly and invisibly. Old carpenters did not have the luxury of assuming stable supply chains or permanent infrastructure. Their methods honestly reflect conditions that are no longer just theoretical. They are practical responses to uncertainty. The mistakes modern builders make are not failures of intelligence or effort. They're really the result of forgetting why older methods existed in the first place. Those methods were shaped by scarcity, observation, and long-term accountability. Understanding what old carpenters avoided helps us see modern construction more clearly. Not with nostalgia, but with perspective. If this kind of historically grounded, detail-driven analysis matters to you, go ahead and subscribe to the channel, and share this video with others who value depth, context, and lessons that honestly endure beyond any single generation of tools or techniques.